Most AI agents are engineered to reason, plan, and execute with impressive sophistication. But there's a fundamental gap that kills nearly every agent project before it reaches its potential: the ability to remember. Without persistent, structured memory, even the smartest agent is essentially starting from zero every single session, wasting compute, wasting time, and frustrating every user who expects it to learn. Engineers routinely invest weeks perfecting prompt design, tool integrations, and multi-step reasoning chains. The agent becomes genuinely impressive until it needs to reference something from a prior session. It can't recall what it tried last Tuesday, can't build on a pattern it discovered 3 runs ago, and can't accumulate expertise over time. The smarter you make the reasoning layer without fixing memory, the more painful this ceiling becomes. The instinctive fix is a flat file, a SKILL.md, a notes.txt, some document the agent reads at startup and appends to at shutdown. It feels elegant and lightweight, and for the first few days it genuinely works. But as the file grows, retrieval degrades rapidly. The agent starts contradicting earlier entries, important facts get buried, and you end up feeding a 4,000 token preamble that the model partially ignores. The file becomes noise instead of signal. The actual solution isn't more sophisticated prompting. It's giving your agent a proper database as its memory layer. Not because databases are technically impressive, but because memory itself has inherent structure that flat files cannot represent. Skills are used at different frequencies. Some knowledge is task-specific, some is universal. Some facts should expire as the world changes. A database lets you query, rank, filter, and update with surgical precision instead of drowning in an undifferentiated text dump. The practical pattern looks like this. Instead of dumping all stored knowledge into the context at the start of every run, the agent queries its memory store at the moment a task begins, pulling only what's relevant to the specific work at hand. When it completes the task and learns something new, it writes structured, indexed records back into the database. The result is dramatically better coherence across sessions, and the agent's context window stays clean and focused, rather than bloated with irrelevant history. Here's the most important distinction. A flat file accumulates, but a database compounds. Every new entry in a file makes retrieval slightly harder and context slightly more cluttered. But every new record in a structured database, if designed well, makes the entire memory store more useful. The agent can identify patterns across hundreds of past tasks, recognize what strategies worked in similar situations, and build genuine expertise that transfers. This compounding effect is the actual goal of persistent agent memory. The framing matters as much as the implementation. When you think of agent memory as a file, you design for storage. When you think of it as a second brain, you design for retrieval, relevance, and growth. Agents operating across multiple sessions, handling diverse task types, or expected to improve with experience will always hit a hard ceiling with the file approach. The file was never a foundation. It was always a temporary scaffold. The database is where real agent development begins. The counterintuitive lesson from serious agent development is this: build the memory layer before you optimize the reasoning layer. When an agent doesn't have to rediscover the same facts every run, the reasoning on top becomes dramatically more efficient and less expensive. Every token spent relearning known information is wasted. Invest in structured memory architecture early, and every capability you add afterward compounds on a foundation that actually holds. That's how you build agents that get better over time, instead of just getting bigger.